Now, if you're given a system of equations, for example, this system, which I think is the same as the system that we just looked at, what's your first step? Well, you take half of this first equation, you get this. Then you write down the second and third equation, and then you can proceed as we just indicated. Now, what if you had these three equations? Well, the first step is to get a 1 here. You don't have an x term here. You can't just get a 1 term. If you write down the matrix or the augmented matrix in this for this, you don't have any way to get a 1 in the first row, except that you do. All you have to do is swap 2 rows. Okay? So if we swap the first and second row, we still have the same system of equations. Okay, there's the same system. It has exactly the same set of solutions, but now you have it in a form where you can get a 1 in front of your x. And it's convenient to have a 0 on your x here because that's a step you won't have to do. But you're still going to have to, multiply this by 1/2 and then add -7 times the resulting row to this one to get rid of this x. All I got to do is multiply by 1/6 here. You get your 1 here. And you've got a 0 here, except you won't after you add a multiple of the first row, so you are going to have some work to do here. But it all works out very nicely. So you can always swap rows of an augmented matrix without changing your solution. And that's the bottom line. So if you want to follow the algorithm, the procedure that we followed in the preceding, you can. Now remember, it's always possible that in getting like a 0 here, you also get a 0 here. That's not going to happen with these equations, but or you could even get 3 zeros down here equal to something that isn't 0, which would tell you there's no solution to the system. So the whole procedure of getting a 1 and a column of zeros and then proceeding to get your identity matrix probably works, but might not. Okay, and if it doesn't, you have to know what to do about that. And we didn't want to talk about that too much, but we alluded to it a couple of times in our preceding videos. Okay, now let's just take a typical problem, and we did this in our last 15 minutes when the 177 students were free to go. I do encourage 177 students to stick around, but we're discussing stuff that's probably not going to appear on your test and is probably not going to hurt your homework grade if you can't do it. Although if you can, it's great, and it might actually appear on a test as sort of an extra credit problem, something of that nature. So you're always encouraged to do all the problems you can, but remember it's only a 2-credit course and you don't have to do as much work, and you don't have to solve problems that are quite as challenging as some of those for the 285 class. Having said that, we can, it does enhance your understanding to see some of this stuff, and something like this in particular gives you a bigger perspective, and it makes you better at the things you will be tested on. So balance out the extra 15 minutes versus what else you might be doing with that time, and if it's worth it, do try to stick around at least whenever you can. Okay, so the question is, if we have this system of equations, okay, well, if this system reduces to this matrix, then what is the value? What can you say about the values of k? Okay, when I say what is k, that doesn't, the way that's stated, that probably